Welcome to the Chocolates class. In this video, we are going to study about respiratory volumes and capacities. Respiratory volumes are also called lung volumes. The lung volumes change during inspiration and expiration. During inspiration, the lung volume increases. During expiration, the lung volume decreases. Accordingly, the respiratory volumes also adjust. To study about these volumes, one instrument is required. Its name is spirometer. In this diagram, two types of spirometers are shown. One is the conventional spirometer and another is the digital spirometer. The graph obtained by this spirometer is called spirogram. We'll analyze the spirogram at the end of this video. This is the lung and this is the volume of the air present in the lung. Or we can say lung volume or lung capacity. The lung capacity depends upon anatomic build, age, respiratory disorders and the gender and other factors also involved. In a healthy person, in one young individual, the average lung capacity is 5700 ml. That is, his lungs can hold maximum 5700 ml air. At a normal respiration, the lung capacity is not that much maximum, 5700 ml, or it may not be zero. The moderate volume of the lung is 2700 ml. After normal expiration, it may reduce to 2200 ml. This is the moderate volume of the air at a normal breathing. The moderate volume of the lungs is 2700 ml. At a normal expiration, about 500 ml of air is sent out. The air which is expired during normal expiration is called tidal volume. The lung volume decreases to 2200 ml. This is before expiration. At normal conditions, this is the volume of the air in the lungs. After normal expiration, its volume may decrease to 2200 ml. The volume of air exhaled out in a normal breathing without putting any effort is called tidal volume. That is 500 ml. About 500 ml of air again inspired into the lungs. This is also tidal volume. So tidal volume can be defined as the volume of air exhaled or inhaled during normal breathing or normal respiration is called tidal volume. Tidal volume is 500 ml. After normal expiration in the lungs, about 2200 ml of air is present. By forceful contraction of the muscles, some more amount of air can be exhaled out. That is called expiratory reserve volume. This expiratory reserve volume is 1000 ml. It may vary 1000 to 1100 ml. In this case, we have taken 1000 ml as expiratory reserve volume. After forceful expiration, the volume of air remained in the lungs is called residual volume. It is about 1200 ml. This cannot be detected or measured by using spirometer. After normal inspiration, the excess of air inhaled by the contracting of inspiratory muscles is called inspiratory reserve volume. After normal expiration, the total volume of air inhaled by the contraction of the muscles is called inspiratory capacity. It includes TV, tidal volume plus inspiratory reserve volume. So the inspiratory capacity is around 3500 ml. Look here, inspiratory capacity. Inspiratory capacity is the inspiratory reserve volume plus tidal volume. You know that tidal volume is the volume of air inhaled without putting any effort is called tidal volume, that is 500 ml. Excess volume of air inhaled by the contraction of the inspiratory muscles is called inspiratory reserve volume. This is 3000 ml. It may range 2500 to 3000 ml. Inspiratory reserve volume and tidal volume together called inspiratory capacity. This is 3500 ml. Expiratory reserve volume plus tidal volume is expiratory capacity. This is 1500 ml or 1500 ml is the expiratory capacity. Functional residual capacity. At the beginning itself, I told you what is functional residual capacity. After normal expiration, the left out air in the lungs is called functional residual capacity. It includes expiratory reserve volume plus residual volume. You know that residual volume is 1200, expiratory reserve volume is 1000. So the functional residual capacity is 2200 ml. Vital capacity is expiratory reserve volume plus tidal volume plus inspiratory reserve volume. This is 4500 ml. TLC includes ERV, expiratory reserve volume plus tidal volume plus inspiratory reserve volume plus residual volume. This is 5700 ml. In other words, we can say that the maximum lung capacity is called total lung capacity. The total lung capacity is 5700 ml. That is about the respiratory volumes and respiratory capacities. So this is moderate lung volume. Assume that this is a 2700 ml and this is the trachea. In this trachea, 150 ml of air is present. This air doesn't participate in the gaseous exchange and it is not useful for the exchange of gases. Only the air present in the alveoli is useful for the exchange of gases. So this is the functional space of the lungs and this is the dead space where the exchange of gases doesn't occur. This is called anatomical dead space. The volume of air in anatomical dead space is 150 ml. So this condition we can find after inspiration, before expiration. During expiration, what happens? Let us see. Normal expiration. Without putting any effort, what changes will occur in this air? Let us see. During the expiration, the air is sent out from the lungs. First, the air present in the dead space is pushed out. Later, the air which undergone gaseous exchange here, that will be sent out. So that is how much? 500 ml. Tidal volume is the 500 ml. But in that 500 ml, 150 ml remains in the dead space. So we called it as a whole alveolar air in a dead space I called. Assume that after gaseous exchange, this air we call it as whole alveolar air. In this whole alveolar air, 500 ml will be sent out or 500 ml will be sent out from the lungs. In that one, 150 ml remains within the anatomical dead space. Out of the 500 ml, 350 ml of whole air and this air in the dead space, earlier air in the dead space 150 ml, these two will be exhaled out. So the tidal volume remains 500 ml. In that one, 350 ml is the old air from this alveoli, means after gaseous exchange, the carbon dioxide containing air, old air. The 150 ml is the air present in the dead space before the expiration. The air present in the dead space doesn't undergo any gaseous exchange. Here it has the oxygen. The old alveolar air, oxygen is taken into the blood, but in the dead space air, oxygen remains. So the mixed air, that is the old alveolar air 350 ml and dead space air 150 ml is expired out during expiration. During inspiration, what happens? Let us see. Here, this colored air shows the fresh air. During the normal inspiration, a person inspired fresh air, that is the tidal volume is the 500 ml. In that one, 150 ml will remain within the dead space. This is the freshly inspired air in dead space, 150 ml is there. Out of 500 ml, 350 ml fresh air is there. That fresh air pushes this air present in the dead space. So, the dead space air, old alveolar air of dead space. This was the old alveolar air in the dead space, no? That again comes back into the lungs, and 350 ml of fresh air is added to the lungs. So, in this way, during inspiration, the freshly inspired air is 350 ml. The old alveolar air present in the dead space 150 ml is added to the lungs. Pulmonary ventilation is the tidal volume into rate of respiration. That is the pulmonary ventilation. You know that the tidal volume is 500 ml. Rate of respiration may vary 12 times to 16 times per minute. So here we have taken 12 breaths per minute. So 6000 ml is the pulmonary ventilation. This pulmonary ventilation is calculated per minute. So this is called minute ventilation. This minute ventilation may range from 6000 ml to 8000 ml, because if the rate of respiration is 12 times per minute, it is 6000 milliliters. If the rate of respiration is 16, then it becomes 8000. So the minute ventilation or pulmonary ventilation is 6000 to 8000 ml. But one should not confuse with the lung capacity. Lung capacity is 5700 ml. It depends on anatomic build, age, respiratory disorders, and gender, and other factors. But pulmonary ventilation depends on rate of respiration, number of breaths per minute. So anyhow, pulmonary ventilation or minute ventilation volume is 6000 to 8000. Here it is shown 6000 by taking 12 breaths per minute. Alveolar ventilation explains actual exchange of air in the lungs. This is equal to tidal volume minus volume of dead space. You know that tidal volume is 500 and the volume of air in the anatomical dead space is 150. So 150 ml is not participating in actual exchange of gases. Only 350 ml is involved in the exchange of gases. So tidal volume minus volume of air in dead space into respiratory rate per minute. The respiratory rate, as we discussed earlier, it may range 12 to 16 times per minute. Here we have taken 12 times per minute. So 350 ml into 12. This is 4200 ml. This is the alveolar ventilation. Suppose if it is 16 times, we have to multiply this 350 ml with 16. That is the alveolar ventilation. So alveolar ventilation gives us an idea of actual exchange of gases in the lungs. And this spirogram is taken from the spirometer or spirometry. Tidal volume is the volume of air inhaled or exhaled in normal breathing is called tidal volume. This is 500 ml. After normal inspiration, the additional volume of air inspired forcefully is called inspiratory reserve volume, which is 3000 milliliters. It may range 2500 to 3000 milliliters. After normal expiration, the volume of air which is forcefully exhaled out is called expiratory reserve volume. This is about 1000 ml. This part is the residual volume. Residual volume is 1200 milliliters. By the spirogram, we can get three types of volumes. One is the tidal volume, next inspiratory reserve volume, and third one expiratory reserve volume. But residual volume we cannot measure with the spirogram. The combination of volumes are called respiratory capacities. Let us take this one. Inspiratory reserve volume and tidal volume. This is called inspiratory capacity. This inspiratory capacity is IRV is 3000, TV is 500. This equal to 3500. This we can define as after normal expiration, the volume of air which is forcefully inspired is called inspiratory capacity. See, I'll explain. After normal expiration, the volume of air forcefully inhaled that contains IRV as well as a TV. So this is the inspiratory capacity 3500 ml. Now let us take ERV, expiratory reserve volume plus TV. This is called expiratory capacity. Expiratory capacity includes ERV 1000 ml and TV 500 ml. This equal to how much? 1500 ml. Now let us see the combination of these two, ERV and RV. Expiratory reserve volume plus residual volume. This is called FRC, functional residual capacity. This equal to ERV 1000, RV 1200. So 2200 ml is the FRC. Now let us see from here to here. This includes IRV plus tidal volume plus ERV. This is equal to vital capacity. Vital capacity includes inspiratory reserve volume, tidal volume, expiratory reserve volume. This is called vital capacity. IRV is how much? 3000. Tidal volume 500. 3500. ERV 1000. So this equal to 4500. Now we'll discuss about total lung capacity. The total lung capacity, we call it as a TLC. Total lung capacity includes VC, means all these things, IRV, TV, ERV, plus here residual volume is there, that we have to add. VC is how much? 4500 ml and residual volume is 1200 ml. So this equal to 5700 ml is the total lung capacity. Thank you for watching the Chockless class.